For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. Once, it seemed the space between Earth and the stars was empty, except for the moon and a few planets. Once, it seemed the solar system was a benign place where life, once established, could develop in peace. Once, it seemed we would only ever be able to touch distant worlds by going there. But now we know, sometimes those worlds come to us, with devastating results. Earth is by no means alone. The vast corridor of Earth's orbit around the Sun is also crisscrossed by asteroids of varying size. The largest asteroid of all is Ceres. At nearly 1,000 kilometers across, Ceres is just big enough for the Hubble Space Telescope to see its rotation and make out a few blurry surface features. Ceres is no threat to Earth. Like hundreds of thousands of other asteroids, it is safely confined to the asteroid belt. This zone between the orbits of Mars and Jupiter is full of rocky debris left over from the birth of our solar system. But sometimes, even the slightest gravitational nudge can send asteroids drifting out of the belt directly across Earth's path. But asteroids are not the only hazards we have to worry about. Comets can be seen coursing through the solar system like guided missiles, trailing brilliant tails of dust and gas behind them. Although they are made of ice and frozen gases rather than rock, comets move so fast that a direct hit from one could release even more destructive energy than an asteroid strike. This was vividly demonstrated in 1994, when comet Shoemaker-Levy 9, after breaking up into several pieces, slammed into the atmosphere of Jupiter. It gave the solar system's largest planet a series of black eyes so large they could easily be seen by the Hubble Space Telescope orbiting Earth. For centuries, astronomers thought of the solar system as an orderly place where the planets, including Earth, quietly went about their business. Today, we realize the solar system is really more of a cosmic shooting gallery, full of asteroids and comets that could threaten life on Earth. That's why exploring these objects is not just a quest for science, but a question of survival. Today, we can still find scars where violent collisions rattled our planet long ago. On Earth, wind, water, and glaciers have erased most of the evidence of ancient craters. Not so on the Moon. Here we find a surface almost entirely covered in craters, preserving the record of a violent bombardment that has accumulated over billions of years. One of the most prominent and recent lunar craters is Tycho, which formed about 100 million years ago. At that time, scientists suspected a collision in the asteroid belt may have sent a wave of rocky debris heading our way. One piece hit the Moon, forming Tycho. Another piece struck Earth, wiping out the dinosaurs and changing the history of life on our planet forever. Our first real look at the asteroid belt did not come until the 1990s, when the NASA Galileo spacecraft made close passes of 2 asteroids on its way to Jupiter. The first, named Gaspra, is only 18 kilometers long. In contrast, the asteroid Ida is over 3 times larger, and it came with an extra surprise: a miniature asteroid orbiting around it like a moon. These early glimpses set the stage for the first dedicated mission to visit an asteroid. Eros is 35 kilometers long and one of the largest Earth-approaching asteroids. And though it is not currently on a collision course with Earth, it presents the perfect opportunity to study up close the kind of asteroid that could one day pose a threat. Unlike a planet, which has uniform gravity at all points on its surface, the irregular shape of Eros means its gravity varies greatly from point to point. It is also spinning rapidly, tumbling through space. Orbiting such an object is no small feat. Despite this formidable challenge, NASA's Near-Shoemaker spacecraft made detailed maps of the surface of Eros and measured its mineral composition. It found Eros is loaded with rock and metal, with a density similar to Earth's crust. As the mission neared its end, controllers brought the spacecraft closer and closer, expecting it to eventually crash land onto Eros. To their astonishment, the spacecraft survived the landing and managed to transmit images of its final descent to the surface. Getting a spacecraft to reach out and touch an asteroid is a tall order, but doing the same with a comet is an even taller one. Comets originate in the distant outskirts of the solar system, in a region called the Oort cloud, well beyond the reach of any spacecraft or telescope. Only occasionally does a comet sweep into the inner solar system, where the sun's heat warms its icy surface, forcing it to spew vast amounts of gas and dust. In 2004, the Stardust spacecraft took a perilous journey to Comet Wild 2 to see it up close and capture a few particles streaming from its surface. Stardust showed us a tiny world, utterly different from anything seen before in the solar system. It is riddled with circular depressions, resembling craters, but with steep walls where gas could be venting into space.
Got a trail. Your cement has a great view. Hey, on the ground.
Stardust eventually traveled back to Earth with a capsule containing samples of the comet's dust. Some of the dust grains appear to predate the solar system itself. If so, they offer a direct window into the ancient nebula that created the Sun, planets, and all life on Earth. Meanwhile, the Deep Impact mission took a different approach. Before arriving at Comet Temple 1, the spacecraft split into two pieces. One piece headed straight for the comet, smashing into its nucleus and raising a plume of material into space. The other part flew by to witness the event and analyze the pristine material ejected by the sudden explosion. Coated in a fine dusty powder, the comet's icy interior is rich in organic compounds, precisely the kind of matter that may have once jump-started life on Earth. There is an irony in these results. Our interest in comets and asteroids is motivated partly by the danger they pose to life on Earth. But it's quite possible that without comets and asteroids and the organic materials they bring, life might not have even started here in the first place. Like the planets, the comets and asteroids are unique and teach us something about our own place in the universe. That's the upside to living in a shooting gallery. It may be a bit scary out there, but it's never dull. For explorers in search of all that is strange and different, our solar system holds many rewards. In its sweeping vistas, the cosmos supplies unending variety. Rendered from the most basic ingredients: ice, metal, gas, and rock. The planets and moons have become nature's laboratory, where over billions of years, the laws of physics and chemistry have yielded masterpieces of astonishing complexity and beauty. It inspires the imagination, leading us to wonder if all we have seen so far could be repeated again and again in countless solar systems across the universe. Once astronomers realized the Sun is just one star among billions and the Earth just one planet, it was natural to assume other worlds existed beyond our solar system. But finding those worlds is a technical challenge of the highest order, and it has taken nearly 4 centuries since the invention of the telescope to do it. In fact, the first concrete evidence other planets exist didn't come from finding the planets themselves, but from finding the places where planets are born. Peering across 1,500 light years, the Hubble Space Telescope zooms in on the Orion Nebula. It is a giant stellar nursery where stars are forming by the thousands. The brightest shine with an intensity greater than 200,000 suns, lighting up hydrogen and other gases, producing a dazzling and colorful spectacle. But deep in the nebula, Hubble can also see what earlier telescopes could not. These tiny, tadpole-like shapes are infant solar systems under construction. Some look dark in contrast to the glow of the surrounding nebula. That means they contain dust as well as gas. It is in these dusty cocoons where planets are most likely to form. If it's happening there, then it is easy to imagine the same thing going on throughout the universe. If so, there must be countless solar systems out there waiting to be discovered. Using a device called a coronagraph, Hubble can block the bright light of a nearby star to probe the space immediately around it. In some cases, this has allowed the Space Telescope to spy the faint, reflected light coming from a disk of dusty debris that surrounds the star. Some disks are seen face-on, others edge-on. Their presence is another favorable sign for planet hunters, because the dust they contain is generated by the collisions of asteroids or comets orbiting around young stars. And where comets have formed, it's likely planets have formed too. When applying this method to the bright star Fomalhaut, Hubble finds not just a disk of dust, but a ring. The fact the region inside the ring is relatively dust-free may indicate most of it has gone into building planets. These views offer tantalizing hints that planets must exist around other stars. But pinpointing those planets more directly requires a different strategy. If a star has a planet orbiting around it, gravity will pull on the star, causing it to wobble back and forth. Although this wobble is slight, in some cases it can be measured from Earth, which tells astronomers where there are planets, how far they are orbiting, and how massive they could be. Once astronomers perfected this technique in the 1990s, they began to see evidence for planets around many nearby stars. The real surprise is how different these planets are from anything we know in our own solar system. Although most are comparable in size to Jupiter, many are also closer to the stars they orbit than Mercury is to our Sun. Astronomers have dubbed these new planets hot Jupiters. The discovery of hot Jupiters came as a complete surprise. Although astronomers expected other solar systems might be somewhat different than our own, no one imagined a difference so extreme. Despite all the variety we have uncovered in our own solar system, the range of possibilities beyond the solar system appears to be far greater. As technology has improved, so has our ability to detect signs of smaller planets. And now, for the first time, planets just a few times more massive than Earth are beginning to turn up. The best way to understand what these super-Earths are like is to catch one passing in front of the star it orbits, like a miniature eclipse. Because the planet blocks a small fraction of the star's light when this happens, it's possible to measure its size as well as its mass. This can tell astronomers whether the planet is dense, containing lots of rock and metal, or more like an ocean world with a thick layer of water or ice.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, start 1, 0, and lift off the Delta II rocket with Kepler on a search for planets in Sunday like Earth.
To find Earth-sized planets like this, NASA has launched the Kepler spacecraft. Its mission is to stare at more than 100,000 stars for more than 3 years, waiting for their light to momentarily dim as planets cross in front. Some of those planets will be gas giants like Jupiter, but it's expected at least a few will be Earth-sized. By spotting these Earth-sized worlds, Kepler will be identifying the targets for future exploration by giant observatories in space. These follow-up missions will be vital, since they will probe the worlds that Kepler discovers for signs their atmospheres contain water or oxygen. This will help distinguish worlds like ours that may support life from worlds like Venus, which are similar in size and mass but completely sterile. Working toward this goal, astronomers are now improving their ability to directly capture the light of distant planets with existing telescopes, and they have succeeded. Returning with the Hubble to look at Fomalhaut with its dusty ring, they have even spotted a planet there. It has moved over a 2-year period, which confirms this tiny dot is not a background star, but a real planet. The planet is estimated to be no more than 3 times the mass of Jupiter, but it orbits Fomalhaut from a distance that is more than twice as far as Pluto from our Sun. This is not a planet where we expect to search for life, but with a distance of only 25 light-years from Earth, it could be one of the nearest worlds to our own solar system, and perhaps the destination of a robotic mission centuries in the future. The number of planets that have been seen directly is growing fast. Meanwhile, more than 300 planets have been found indirectly, nearly 50 times the number in our own solar system. The last 15 years have seen a revolution in our ability to find and study planets beyond our solar system. The next 15 could be even more exciting, as Kepler and its successors try to zero in on planets like Earth and then hunt for signs of life on those worlds. The glorious cosmic vistas we've been granted by our spacecraft explorers and orbiting telescopes carry a message. In a universe as vast and incredibly diverse as this, there are many possibilities for life, but no guarantees. Until we find other civilizations like our own, we have no way of knowing how rare we are, or what limitations there may be to our future in the galaxy. We stand on the threshold of a new age of exploration, perhaps the greatest in human history. Now, more than ever, we need to recognize the most astounding planet we've ever encountered in the universe is the one we call home.